Hello and welcome to the video lecture series on chapter 2.3. We're going to be looking at one quantitative variable again. 2.2 and 2.3 are looking at just one quantitative variable at a time. In the last section, we looked at measures of center. In this section, we're looking at measures of spread. All right, so the topics we're going to cover in this chapter in this video lecture series are standard deviation, z-score, 5-number summary, range, and IQR, which is interquartile range, and percentiles. But first, let's do a quick review. The exam scores shown in this histogram. Would you say this distribution is symmetric, left skewed, or right skewed? And hopefully you guessed left skewed, because if we draw a curve on top of this tail is going towards the left. The skewness follows the tail. Okay, so the first measure of spread is called the standard deviation for a quantitative variable, and this measures the spread of data. So here you have the formula, and I want to go through this formula a couple times with you guys for very small data sets. But in practice for the rest of the semester, I care more, can you interpret what the standard deviation says, use it, or calculate it with technology using a StatKey or some other software package. But I like going over standard deviation, at least a couple examples, just to see how this formula works. And the notation for standard deviation is S for sample. Sample standard deviation uses S. And population standard deviation uses the designation of sigma. It looks like a little kind of a scripty O, the Greek letter sigma. And I'm going to go to the next slide to show that I'm going to look at three different data sets to calculate the standard deviation. But if you break this down, I'm going to ignore the square root. What we're doing here is we need to calculate the mean, figure out the distance between each value and the mean, square it. The idea is we're squaring this because we don't care if the data point is above or below the mean. We want to square that negative away if that's possible. And then I'd like to say we're almost taking an average. We're going to take an average of the squared distance from the mean. So divide by n minus 1. That's why I say almost an average, we divide by n minus 1. And then if we square something, the way to undo a square is to then take the square root. Okay, so what I want to do right now is calculate the standard deviation for the following three data sets: 8, 9, 11, 12, 0, 0, 20, 20, and 10, 10, 10, 10. And take a second, think about these three. How would you rank these in terms of spread? I think I picked these data sets specifically to see that one of them definitely has more spread than the other two, and then one of them has almost no spread. Let's see, data set C has 0 spread. All right, so I want to look at this. All right, so for data set A, what I like to do is set up a table. We have 4 data points, so I'm going to create a little table. In this table, I'm going to put x of I. I'm going to put all the data points in. I also want to figure out what is x each data point. How do they differ if we subtract from the mean? And then what I want to do is then take that value, the difference from the mean, and then square it. So the first thing we have to do is figure out, well, what is the average between these 4 data points? And again, we would add them up: 8 plus 8 plus 9 plus 11 plus 12, divide by 4, and you should get 10. So our value is 10. So then for each of these values, let's see, center all this so it's easier to read. For the first value data set, we have 8. Then we're going to have 8 minus 10 equals minus 2. And then finally, we're going to take the value before, minus 2, and square it to make it 4. Let's go through this process. For 9, we're going to do 9 minus 10 equals minus 1, because this data point is 1 lower than the average. And then take that number and square it to get positive 1. Now if I take 11 minus 10, that's positive 1. If I square that value, 1 squared is just 1. And then for 12, I'm going to take 12 from 10, or 10 from 12. I have 2 left over, and then squaring that value gives me 4. So before we go on, we need to use this table to create the standard deviation. Here we have the second column is just the distance from each data point minus the mean. Then we square that value, because the idea is we just want to know that 8 is 2 away from the mean, is the same as 12 being 2 away. So they're both 2, just one is below, one's above. So we square it, we get the same value for those two. And now we say the variance is denoted with an s squared. And that would be if we take that almost average. We're going to take the sum of the squares and then divide it by the number of observations, the size of the data set, minus 1. So that's going to equal 10 over 3. And we'll approximate that to about 3.333. All right, this is the variance of this data set. So then the standard deviation is S. It's the square root of the 3.333. And that would be approximately, I'll throw that in my calculator, 1.826. All right, like going over like 3 small data sets, going over these by hand or manually calculating the standard deviation, because I think the best way to get this down is to compare data sets. So if we do data set B, here we have the mean of this data set. If you add these up, 0 plus 0 plus 20 plus 20 divided by 4, we get 10 again. I expect these averages to all be the same. And if we do the same thing, insert a table. Make this a little bit bigger. All right, so here we've got the same exact setup. We're going to start with right here. I've got 0, 0, now 20, and 20. And then here I'm going to take 0 minus 10 equals minus 10. And then take that value, minus 10, square the whole thing, including the negative, to get 100. Second data set, I still get 0 minus 10 equals minus 10. And square that value to get 100. I'll do it a little bit faster. But now I got 20 minus 10 here is positive 10. And if we square that, we're going to get 100. And same thing here, 20 minus 10 to get 10. Square that value to get 100. So notice the squares of the distance from the mean of all data points are 100. So the variance is S squared. And that would be, take the 100 plus 100 plus 100 plus 100. And then we're going to divide by 4 minus 1. So that's what, 400 minus divided by 3. And we get approximation. That's about 133.333. So that's variance. And the last step we need to do is calculate the standard deviation. And you just take the square root of the variance, 133.333. And throw that in your calculator. I got that to be 11.5 1.547 if we're rounding to 3 decimals. So here, if we look, I got the standard deviation of the first set. I'm just going to write over here. Standard deviation is about 1.826. Second data set, my standard deviation is about 11.547. All right, and the third data set. Let me move this up a little bit. All right, we could go through this whole process again, but imagine the average of this data set is 10. Everything's 10. The distance from each data point from the mean is 0. For the data set C, I'd have a column of zeros, and you square a bunch of zeros, you still get 0. Here we would get 0. There is no variation from the mean. No spread. So if there's no spread in the data set, standard deviation should be 0. And the idea that the actual value of the numbers, kind of difficult to figure out what that means. But the idea I want you to take away from going over these, at least 2 examples in detail, is the larger the standard deviation, the larger the spread. The smaller the standard deviation, the smaller the spread. So even though this mean for both of these 2 data sets was 10, for data set A, the 4 numbers are fairly close to 10. For data set B, you've got all numbers are a lot farther away from the mean than in data set A. And then to the extreme case, data set C, everything is the same, no variability, no change. So we have a 0 standard deviation. So standard deviation gives a rough estimate of the typical distance of a data value from the mean. And the larger the standard deviation, the more variability there is in the data and the more spread out the data are going to be. All right, let's look at just a couple of histograms that highlight this as well. Here we have 2 different histograms, both centered at 0. So we would say both of these distributions are symmetric and bell-shaped. And they're both centered at 0. So we would say the mean and the median is 0 for both of these distributions. But this first distribution, the standard deviation is 1. Notice how closely compact and tight the values are. Whereas the second distribution, the standard deviation is 4. So the histogram, the values of the data set are a lot more spread out. Okay, we'll continue going over chapter 2.3 in the next video.